Hey there, how about we continue to work in Chapter 2 with Section 2.3, Analyzing Graphs of Functions. Welcome back. We'll be looking at the objectives of using the vertical line test for functions, finding zeros of functions, determining intervals where a function is increasing or decreasing, find relative maximum and minimum values of functions. An important thing is average rate of change. That actually is a concept that you'll need if you go on to calculus. And then determining if our functions are even, odd, or neither. So let's first take a look at some graphs of a function. So a graph of a function is just a collection or a set of all the ordered pairs for that particular function or equation. Remember that the domain represents the x values and the range represents the y values for a particular function. So from a graphing perspective, the domain values are all the values that your graph takes on along the x-axis. So all the domain values are all the x values that your graph would basically cover. So if I just looked at this graph, the domain would start here and stop there. Those would be my domain values. Starting, always go left to right, start on the left, stop on the right. If I were to look at the range values, well, that's what happens on the y-axis. So I would look at my y-axis here and see where is the topmost value. So my y values start here, and you notice the bottommost y value would be there. So this is my range. And to find out what the range is, you go to the bottommost value, which would be right here. That's where the range would start. And then I would continue to the topmost value, and that's where my range would stop. So it would be an interval starting to stopping point. So just a little information about a graph, about its domain and range values. Also, a very key part is to realize that f of x is the same as saying y. They're interchangeable. So if I had an equation y equal 2x plus 3, that's the exact same equation as f of x equal 2x plus 3. Just keep in mind, they say the exact same thing. Okay, so let's look at some definitions. X-intercept, very important. It is where the graph crosses the x-axis. And that ordered pair will be some number, comma, 0 as an ordered pair. The x-intercept is also called the zero of a function. Another important point about your graph that you need to know and need to know how to find would be the y-intercept. And that's where the graph crosses the y-axis. And its ordered pair has a 0 in the x spot and a constant in the y position. So notice an x-intercept, you basically have a 0 for y, and for the y-intercept, you have a 0 for x. Domain, I touched on that, but it's the x values of a function, and we always move left to right. The range is the set of y values of a function, and we always move bottom to top. And we'll practice those. So let's review something called interval notation. Interval notation is a mechanism we can use to represent a set of values that has a distinct starting point and a stopping point. So some aspects about interval notation that we need to know is that whenever our graph goes out to the left and to the right or up or down and never stops, we're going to use the infinity symbol. And we'll just use, I'm sure you've seen it before, that infinity symbol. When we use our infinity symbol, we have to always put a grouping symbol next to it, and it will always be a parenthesis, whether your interval starts with infinity or your interval ends with infinity. Infinity always has a parenthesis associated with that. So if it starts with infinity, it gets a parenthesis. If it ends with infinity, you get a parenthesis. If you go all the way to the left, negative infinity, all the way to the right, positive infinity. And when you have your interval notation, be aware that it has to be in number order. If I had an interval notation that looked like this, let's say I had a bracket and a 2, a comma, a -5 with another bracket. That would be an example of interval notation. But it would be wrong because these two guys are not in number order. When you set up interval notation, you have to have the smallest number first, the largest number second. This would be correct. This would be wrong. Keep that in mind. Also, if your graph has an open dot on one of its ends, then that means that point is excluded, and on that value we have to use a parenthesis. So we use a parenthesis for the endpoint if we have an open circle or open dot, and if our graph contains a closed dot on maybe one of its endpoints, then the closed dot means that value is included, and we would use a bracket on that type of endpoint. Like you see over here, a bracket and a bracket, that means the -5 and the 2 are both included, and so there would have been a closed dot on those points on our graph. So our format for our interval notation will either be a parenthesis or a bracket, the smallest value, comma, the largest value, and then a parenthesis or, a bracket. So here are some examples. Of interval notation. This example A, 5, 10. There's a parenthesis on the 5 and a bracket on the 10. That means this set of values starts at 5, but it doesn't include the 5. Then it stops at 10, and it does include the 10. Here, notice negative infinity to positive infinity. Infinities always have parentheses. Here, my starting value is 0, and it's included. It stops basically at infinity, so it never stops, and always use a parenthesis with infinity. Here we have a starting point of -9, ending point of +9. Brackets means they're both included. And finally, starting point -3, stopping point +3. Parentheses means both of those values are excluded. Notice in all of these examples, the smaller of the two numbers comes first. +5, +10, 5 is smaller than 10. It has to come first. 0 is smaller than infinity. -9 is smaller than 9. -3 is smaller than 3. The smallest number has to come first. Now, based on that discussion, I want you to determine why these sets of interval notations would be incorrect. Pause it, take a look at them, and see if you can figure it out. Did you find the error in part A? What did you notice? What's wrong with it? It has a bracket on infinity. Never have a bracket on infinity. It should be a parenthesis. So there's the error in that one. What's the error in the second interval notation? Did you catch it? The smaller number is not first. To correct it, It'd have to be -3 to +3. Okay, what's the error in part C? The error is the smaller number is not first, because this is a positive infinity, and 0 is smaller than a positive infinity. So the 0 would have to come first, the infinity second. Has to be in number order. Finally, you see the error with D? Negative infinity should come first because it's smaller than positive infinity. Okay, so let's look at some examples and let's go ahead and create some interval notation to represent domains and ranges and stuff. So let's take a look at this example. I'm going to use this graph, and I want to first find the domain, I want to find some function values, and then I want to find the range. So remember, the domain is what happens as we go left to right. So as I go left to right, on the left side, my graph starts here, it continues, and it stops there. So the starting point for the domain, we always go left to right. The starting point is 1. The ending point on the x-axis is 5. But what type of symbols do I put on those? I have to have a parenthesis or a bracket. Why do I put a bracket on the 1? Because it has a closed dot. Why do I put a parenthesis on the 5? Because it has an open dot. Notice x value -1, x value 5. Whoops, that is a -1. Sorry, forgot about that. I missed that. All right, let me erase this. And let's look at range. So now range, I move from the bottom to the top. The bottommost point on this graph is here. The topmost point on this graph is there. So there is my range. So where does it start on the y-axis? It starts down here at -3. It's my y value. As I go up, it stops here at what? +3. A y value. What type of symbols am I going to use on those? Well, notice there's closed dots. So we'll use brackets on both of those. Finally, for this example, let's look at finding function values. So I'm asked to find f of -1, which means I go to -1 on the x-axis. The number inside that f, remember it's f of x, is an x value. So I'm going to find -1 on the x-axis, and I'm going to see what ordered pair corresponds to an x value of -1. And there is my point. It goes -1, +1. So f of -1 is simply the y coordinate, +1. It's just an ordered pair. -1 for x, 1 for y. So if I want to find f of 2, I'm going to go on the x-axis. I'm going to find the value of 2, and I'm going to look for the ordered pair that goes with 2. There's no ordered pair up here. It's the ordered pair down there. So what's the y value that goes with an x value of 2? It's -3. So function values, we can find function values from the graph, and basically it's just the y value from that ordered pair. Okay, let's check another one. Let's check out another example. Okay, we've got a graph to the right. We want to find the domain, some function values, and the range again. Why don't you pause the video, play around with it, and then come back and check your results. So I did the function values first. F of 0, 0 on the x-axis puts me up at 3. So the y value is 3. F of 3, if I go to 3 on the x-axis, that ordered pair is 3, -6. So f of 3 is -6. Let's do domain and range together. When you have a graph, and notice you have these ends of this parabola that's opening down, we're going to assume, since there's no open or closed dots on the endpoints of that graph, we're going to assume it goes to infinity. So it's like there's arrows here. Continues to go down. So here's an interesting thing, or something that'll help you in working with finding domain and range. Hold on, my phone. Okay, took care of that phone call. So the endpoints, we have arrows, and those arrows indicate infinity. So that means it's going down here to negative infinity. Another interesting thing is when you have an arrow in, let's say, a quadrant. So a quadrant would be right here. If I have an arrow in this quadrant, that arrow means it's going down to negative infinity and it's going to positive infinity on the right. This graph just keeps getting wider and wider and wider, and it's going to both negative and positive infinity. So with this arrow in this quadrant, it's going down to negative infinity, but it's also going to the left because this half of this parabola is continuing to go further out, 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 which means it's going to take up all the values to the left, to negative infinity. So I suggest that if you have a graph that has that continues in a particular quadrant, when you know that, automatically put your infinities, because that's going to be part of your domain and range. An arrow, put infinities on both of those ends of those axes. So now, when I go to find the range is from the bottom to the top. And if you notice, on this axis, I have it marked at negative infinity. So that means it's starting at negative infinity and it stops right there at 3. Notice the graph does not go farther than the 3 on the y-axis. It stops at 3. So the range would be parenthesis negative infinity going up to 3. 3 gets a bracket because it's a closed dot. Now, if, when looking at the domain, if this point were solid, my domain would just be negative infinity to positive infinity. You see a negative infinity here, positive infinity there, and for domain I go left to right. So it would be negative to positive infinity if I did not have that open circle. But I have that open circle. And that open circle means something needs to be excluded. I cannot include this value in my domain. So this value right here, negative 3, has to be excluded because of this open circle. So my domain can be everything negative infinity to positive infinity except negative 3. So we have to make an amendment to this domain. It's going to be negative infinity to negative 3, parenthesis on the negative 3 because we need to exclude him. And then we're going to pick up with the negative 3 with a parenthesis to exclude him and continue on to positive infinity. I know it's awkward, but if you've got open circles, you've got to be aware that point needs to be excluded. So left to right, I got to exclude negative 3 on the x-axis. Otherwise, everything else is good. I'll end this video here and pick up with the other information. Always, if you have a question, email me. I am happy to answer any question you may have.